In mechanics and physics, Hooke's law of elasticity is an approximation that states the extension of a spring is in direct proportion with the load applied to it. F equals negative kx, where x is the displacement of the spring end from its equilibrium position, F is the restoring force exerted by the spring on that end, and k is a constant called the rate or spring constant measured in newtons per meter. The most commonly encountered form of Hooke's law is probably the spring equation, which relates the force exerted by a spring to the distance it is stretched by a spring constant k measured in force per length. The negative sign indicates the force exerted by the spring is in direct opposition to the direction of displacement. It is called a restoring force as it tends to restore the system to equilibrium. Potential energy stored in a spring is given by PE equals 1/2 kx squared, which comes from adding up the energy it takes to incrementally compress the spring. That is, the integral of force over displacement. Note the potential energy of a spring is always non-negative. This potential can be visualized as a parabola on the UX plane. As the spring is stretched in the positive x direction, the potential energy increases. The same thing happens as the spring is compressed. The corresponding point on the potential energy curve is higher than that corresponding to the equilibrium position, x equals 0. The tendency for the spring is to therefore decrease its potential energy by returning to its equilibrium or unstretched position, just as a ball rolls downhill to decrease its gravitational potential energy. If a mass m is attached to the end of such a spring, the system becomes a harmonic oscillator. It will oscillate with a natural frequency, given either as an angular frequency, W equals the square root of k over m, or as a natural frequency, F equals 1 over 2 pi times the square root of k over m. This idealized description of spring mechanics works as long as the mass of the spring is very small compared to the mass m. There is no significant friction on the system, and the springs is not overextended beyond its natural range, which can deform it permanently. When dealing with multiple springs, the spring constant adds directly in parallel configuration and reciprocally in a series configuration.